Okay, here we go with the second practice. In this practice, we making a polymer, polyamide. So it's a step polymerization using hexamethylene diamine. We used 9.22 grams, and we reacted with adipic acid, 11.68 grams at some certain temperature. Now, we analyze the polymer. So this is really one of the key ones that this problem has. Not all of them have, but this one has. It says after reacting these two, reactant amine and carboxylic acid, you're going to have some leftover carboxylic acid leftover, and that is going to help us to measure the R and P for this reaction, for this polymer. Anyway, let's go and read on. Now what we need to calculate the Mn of the reaction. And if you know the Mn of the reaction, can we also measure the Mw hat for the reaction? So again, the reaction, we move this a little bit here. The reaction is really reaction between an amine and a carboxylic acid. We know that we have 9.22 grams of the diamine. Now molecular weight for the diamine is 116. So again, we have two groups, two NH2 groups. So we really need to multiply the number of moles by 2. If you don't, then you get the wrong answer. We have to multiply by 2, so that's 0.1590 moles of the diamine. Same thing for carboxylic acid, 11.68 divided by 146. So we get 0.160 moles for the dicarboxylic acid. Again, these are what we put in the reactors, and we also see that the repeating unit is, again, we need to practice repeating units. From these two molecules is NHCH2 4 times, NH, so this part came from the diamine. Then the carboxylic acid reacted with one of the amines to make the amide. So the amide part is here, and this C-double-bond-O is attached to another NH, but we don't show that. So the repeating unit has 2 COs and 2 NHs. So again, let's look at the number of moles. So we have to measure the number of moles for the diamine as 0.1590, for the dicarboxylic acid as 0.1600. Now, the carboxylic acid is, as you can see, is a little bit higher than the diamine. So the ratio of the 2 moles is diamine, the smaller one, to the carboxylic acid. So the R that we're going to use later on as the ratio is 0.9938. Okay, so now look at the X's. What does that mean? So it really means that we have, when we finish the polymerization and we measure how much carboxylic acid is left, a small amount, but we can use it. It's 2.6 times 10 to minus 3 moles of excess carboxylic acid left. We know that for the polymerization to happen, the number of moles of the diamine and number of moles of the diacid have to be the same. They have to be the same. So what is the actual moles of the diamine that we use? What's the actual moles of diamine that we use? So we have to take 0.1600 that originally we had. Again, it's moles, right? Moles and moles. So we're going to subtract the number of moles of the remaining remaining dicarboxylic acid is 2.6 times 10 to minus 3. So that gives us the actual moles of diamine, actual moles of dicarboxylic acid that we use. Again, I forgot that I already measured the R there, so I repeated myself basically here at the bottom of the page. So again, I remeasured the R as 0.1590, which is for the diamine, over 0.1600, 0.99375. Again, we only have 4 sig figures, so it is 0.9938. So we have the R at this point. So the next thing we need to do is to go and measure the P. P, if you recall, is a conversion. So now let's go look at how we are going to measure conversion. So the conversion is really the ratio of actual amine that we use, which we just calculated, 0.1574, over the original moles that we started with, which was 0.1590. So the percent conversion is very high, but it's not 100%. It's 0.9899. Now we have the R, we have the P, and we're going to work on these equations and how to drive it. So at this point, we're just going to use, we know that dP hat is same as xn hat is 1 plus R over 1 plus R minus 2 RP. That's the equation we're going to use. We have the R, we have the P, we just substitute, right, to measure dP hat or xn hat. So that's 1 plus 0.9938 for the R. At the bottom, we have 1 plus R, again, 1 plus 19938 minus 2. R is still the same, 9938 times 0.9899. So dP now is 75.88271. We only have 3 sig figures, so that would be 75.9. So what does it really tell us? It will tell us that we have the number of MER, or dP hat, or the repeating unit at 75.9. We need now to know what the M0 is. So that's the M0 for the repeating unit. Once we have that, then we can measure the Mn. Let's look at that. So we know that for measuring the molecular weight for any polymer, and if you have the dP, we can measure the Mn. So let's look at the repeating unit. So if I have the diamine reacted with the dicarboxylic acid, so repeating unit is this, NHCH2 6, NHCO CH2 4 times, CO. We know the number of nitrocarbon, 12 times 12, 12 hydrogen times 1, 2 nitrogen times 14, and 2 oxygen, which is 2 times 16 is 32. So the whole thing is 226, but remember this is a step polymerization. So we are 2 monomers unit in the repeating unit. We have to divide this 226 by 2. And if you don't, we get a wrong answer actually. So the M0 by definition is 226 by 213. Okay. So now we have everything we need. So we have the dP. So we have the dP at 75.9. We have the M0 as 113. So Mn basically now is multiplication of the dP hat or xn hat times M0. We have 75.113. Again, rounded up for we have 8.58 kilogram per mole for Mn. Remember, Mn is again, Mn hat is the average. So how about Mw? We also want to measure the Mw for this polymer. We know from equation that we're going to draw 3.16. If I have Mw over Mn is 1 plus P. So we have the P. We don't have the Mw, but we have the Mn. So Mw would be Mn times 1 plus P, 8.58, 1 plus 0.9899. So that ended up giving a Mw of 17.07 kilogram per mole. Thanks for your attention.